This conference will now be recorded.
Okay, can you please confirm if you can share see my screen?
Yes, we can see your screen, but your voice is breaking sometimes.
Just now it should be good.
Okay, let's see.
Okay, so I have on the screen you can see over here is I just opened the JVisual VM and the contact VI for the JText. Okay, so let's before we start, let's just get what we are going to discuss now. Okay, so so we already discussed that in the previous session. We already saw that you know setting up the GC options and he walking started the JMeter script that we already shared, and we observed the memory utilization back. So it was something like that. This was a pattern, and then in between when the load started, we see this kind of pattern. Okay, so this is the period where there is consecutive GCs are happening. Okay, so today's topic will be how do you deal with consecutive GCs. Okay, and whether it is a problem or not. How do you identify whether this consecutive GCs is an issue or a problem or problem for your application performance or not. Okay, so this is the topic we are going to discuss now. We will try to regenerate this issue in the today's session, and let's see what is happening exactly. So let's just first understand the basics why consecutive GCs happen and what are the types or what are the remedies that we can cure this. And also we need to also make sure that whether this is actually hampering the performance of the application or not. Okay. So the usual memory cycle you can see over here is, so the heap memory utilization increases, and as soon as its threshold, the GC is being called and the memory has been reclaimed. Okay, so but what happens sometimes, there are the reasons for consecutive GCs are two basic reasons. Okay, first is your object creation rate is very high. If your objects are getting created at very high rate, your impedance space is getting. Second common reason for having consecutive DCs is your Eden space being small. Eden space law, or you can say Young generation. Okay, so these are the two basic reasons, two main reasons why the consecutive GCs happen on your application. So first is what? Object creation rate is very high. What do you mean by object creation rate is very high? That means the rate at which the objects are getting created in the new heap area, it is very high. If we are expecting 10 objects to be created in the heap per second or per minute, it is something greater than that. So like 100 objects are creating per second, over 1000 objects are getting created in per second. And with this object creation rate, one factor also comes in picture is this object size. Okay, because simply the simple objects are getting created, it won't create an issue. The GC will get GC will declare. But if the object sizes are also high for the created object, it will lead to the, I mean, this continuous behavior will lead to the memory leak. Because having high object size and again triggering consecutive GCs to clear the space, will clash together, and that's why it will at one point of time it will heap your GVM will get out of memory error in the heap segment and it will stuck. Okay, second is that hidden space. We already discussed in the JVM architectures and the JVM study, that heap memory study that we did. What is hidden space and what is old space, old generation, young generation. Okay, so if your hidden space is very low compared to the JVM ability, or compared to it's not properly set, so in that case you you will be getting this kind of issues. Okay, voice not clear. Are you not able to hear me clearly, guys? Okay, is it okay now, Chandra? Okay, so we are talking about this hidden space. So if your hidden space is not adequate in the heap, okay, so this also causes the issue of this is your hidden S0 and S1 and old. Okay, so having a large group size is not solve the issue here, because you have the hidden space very slow. This is the first area in your heap where the objects are getting created, right? So you should have adequate space for your hidden. Okay, it's still breaking, guys. Can someone please confirm by speaking, because I'm not able to get on the chat. It's breaking from start.
Yeah, you're breaking up from the onset. You're breaking up. Is very terrible. Yeah, you're breaking up.
Mm-hmm. Okay, so is it okay now? Are you guys able to hear me? Hello? Yeah, I think this is working properly, but can you please confirm if you're able to hear me?
Yes, Chetan.
Okay, okay, so we can move forward. Okay, so what we were discussing about the possible causes of having your consecutive GCs. Okay, so second cause is that hidden space being too small. Because the hidden space is the space where the objects are getting created first. Whenever object is new, that's why we call it as a young generation. Okay, so if this space is not enough for accommodating all the objects which are supposed to be created, in that case, you will face this issue.
Okay, so let's now just try to check that how we can resolve this issue, because now we know the two possible reasons that why consecutive GCs happen. Okay, so the next thing is, so I mean, whenever you observe this kind of behavior, what you have to do in your application is, first thing that you need to identify what is the reason this is happening. Okay, consecutive GC, either is it the object creation rate is high, or is the hidden space low, that's why it is happening, or not. Second thing you need to check is whether this consecutive GCs is hampering your performance or not. So now how do you check it? So let's check in the application. So I have started the Tomcat application already here. Let me just check if it is still running or not. Okay, okay, so I think it's still running, no issue. So we can actually start the test on this application and try to see what is happening on the memory part. Okay, and visual. Okay, so this is working properly. Okay, so we already have a test setup, and I think I already shared the scripts with you guys. So this is how you start the test from the non-GUI mode on JMeter. So you just go to the JMeter bin directory. Okay, I think I am not there in the bin directory. Okay, now I click JMeter -n -t. Then I just need to give the name of your script. JPXT local, yeah. Okay, there should be one more flag for setting up the results. I don't. Hmm. Do you guys have that command handy that I send in one of the recent emails? Hmm. Yeah, this is okay. So what we have done is we have just given this path of the script, and we have just tried to give them a GTL file. GTL file is nothing but just the results file for your JMeter. Okay, so before we start, Let's just check if everything is working fine one more time, and then we'll move to the test. So visual VM we already started, so you can see that. Let's just close it again and open it, so it will start monitoring from the start. Okay, so now you can see it's running properly, everything is moving. Also go to the visual GC tab, you can see everything is moving. Okay, so now let's just start the test and check in the monitor tab that how it is behaving. Okay, so I think we have started the test. Okay, it's already ended. I think I need to do some changes in the script. Uh, yes, because there is only one thread user is given, that's why it got finished so early. So let me give 200 users and wait in seconds. One loop count, let's take it forever. Save it. Let's run it. Okay, so it started now. So now you can see the background in the J Visual VM. You can see this heap space. It's started building up. The users are starting building up. Right. At the same time, you can see this threads. We have given 200 threads. So you can see this count reaches to 200. So why it is higher than 200? The remaining threads are nothing but the daemon threads that are required by your JVM to work, right? So we already discussed in the JVM architecture session. Okay, so now let's check this Visual GC tab. Okay, so now you can see this Eden space utilization being consecutive ups and downs. That means it is having a consecutive GCs over here. Same pattern you can see in the survivor space as well, right? So, and the upper side you can see GC time 83 collections within 1.087 seconds. Okay, now it is increasing. So what it is indicating is that it is you are having consecutive shortage of space or shortage of memory in your hidden area, right? You can see your old gen area is I mean, it's enough to accommodate all those objects, but you can see this there is consecutive spaces. Now you can see this it is started same. I mean, same as the previous before we started load. That means it has some issues over here. If you quickly go over there and see, you can see the error counts increasing now. 172.5% is are erroring out. So that means due to this consecutive DCs, there must be some problem in your application which caused these errors, right? So now for this test, we cannot see the errors live because we are running in non-GUI mode. And once we get the results, we should be able to justify why it is happening. But anyways, we can go and check manually whether the application is still live or not. So it is still live in working, but through the Tomcat manager we can also check about the threads. So all the threads are ready. In service. So error count is 82. So for 82 threads we are getting errors over here. Okay, now it is increased to 173, the same that we saw in the J-meter form. Okay, so how we are going to analyze this part, why this is happening. So we already discussed that object creation rate is one thing, and the second thing is that your hidden space being too small, and we need to check whether it is causing an issue for application performance. So we know that it is causing an issue for our application performance, because we can see that error counts are increasing, and so from the graphs also we can see that it has resumed its proper behavior, but which is not expected under load, right? Because we were expecting the application to serve the requests, whatever requests are coming. Okay, so now let's go to the other tool which we can use to identify why what was the actual basic reason, whether the object creation rate or the hidden space. Okay, so we have already discussed about these tools like GC Weaver and HPG meter, right? So let me just start the HPG meter. Okay, so I've just imported that GC log file in this HPG emitter, and I can see this tab under creation rate. You can see it's suddenly jumped from C. This is the previous at 8 a.m. The previous details, I mean, in the G heap since the application was running from so long, and suddenly when we started this test, you can see this object creation rate has jumped up, right? So one issue is pretty much clear for us now, that object creation rate is very high. You can just try to zoom in and just check. Okay, from this graph also we can identify whether our application is working properly or not. We can see that after this point of time, the object creation rate has suddenly dropped. That means there are issues in the application, and requests are getting errored out, right? So this is the one reason, possible reason, that object creation rate is high. So now who can confirm this particular thing, right? So for this we need to check with the developers of our application, whether whether this is the expected behavior for application with this much load or not. Okay, so we need to set up set up a meeting with the developers and just confirm with them that we are observing this kind of behavior for application under load with this much, and is it expected to create so many objects with this particular criteria, also this particular rate. Okay, in the summary page, you can also see that total duration and everything. So that we already discussed that what are the basic things you can know. So now we are sure that one is the reason. Now this object creation rate is creating an issue. But if the developer confirms that this is the expected behavior of your application for object creation rate, and it should not cause an issue. So that means you need to now check the second option, right? What is the second option is your heap, right? Heap area. So you can see in the screen that hidden space is allocated 84 MB. Okay, it is having only 84 MB. So if you count total, you add the total hidden plus survivor plus old, so it comes approximately 256 MB. So JVM is having 256 MB of space, out of which 171 is your old generation and 84 is only the hidden space. Okay, so there is a chance that we can improve the hidden space area, and we can again try to check if it is showing some kind of improvement or not in the test. So what we can do is we can quickly go and we need to restart our Tomcat with the latest option. Okay. So before we go that, I will also try to show you that catalina.pat file. Okay, so I have given this kind of exercise previously to use the different options and check what is the impact. Okay, so I am using these options now as of now here. So parallel GCs and I'm using the XMX with the heap related parameter, that is XMX 256 MB. So maximum heap allocated is 256 MB. Okay, now what I want to do is I will just change it another, I will add another parameter XMS also 256 MB. Okay, so this is a recommended standard, in general. So you should have your XMS and XMX both at the same level. You know why? Because anyhow, if you're defining XMX, that means you are already telling your JVM or you're instructing your JVM to use maximum 256 MB of space. If you're not giving XMS value, in that case what happens is you can check, you can see here in the monitoring tab your JVM started to acquire from a very low space, right, 50 MB, then it reserved come up to the 150 MB space. It is use space, okay, heap size. Okay, then when you started the object creation rate is increased, now this space is also getting increased, heap size, right? It is JVM is trying to allocate the more space to the heap area. Again, this exercise for JVM, it also takes some sort of memories, and this also triggers your GC cycles. Okay, because if you don't have the heap available at the moment, JVM is trying to allocate the heap from the reserve slot. So XMX is what is the reserved slot, and it is trying to allocate the heap from that slot. At the same time, GCs are getting triggered. So to minimize the number of GCs, you are expected to have this option XMS and XMX both at the same. Okay, so this is the first thing. Next thing is that you, with this combination, you can use some other options as well. Sorry. So we have now we have seen that there is an issue with the hidden space also. So there might be a possible issue with hidden space. So can we control the hidden space with this limit? Right, XMS and XMX is already given. So if I am not allowed to use more than 256 MB for my JVM, can I increase the just hidden space in between that? So yes, for that also we have seen multiple JVM options are available, right? So there is one parameter like -XX max new size. Okay, so I'll just open this PPT, so where we discussed about the different heap sizes and all these things, right? So there is one JVM parameter like -X max new size, right? Okay, so you can see this -XX max new size. So it will set you the maximum size for the new generation of the heap area. Okay, so let's try to use this now. So both we can use. Also, we can use the new -XX new size also. So let's try to use this first. Okay, meanwhile we will just stop this test because it's already erroring out. Okay, so we have already discussed how we change these options in your Catalina, right? So I've just given this. Now I'm putting one more option -XX new size, and I just need to define it. What is the new size? So earlier it is 84 MB. So with 84 I know that it is not sustaining. So let me just give it 120 M. Okay. So this is now updated, but for it to get effect, we need to have the Tomcat restarted, right? Because we are changing these options, but before that, we need to restart the Tomcat. How do we do that? We already know. Just go to the bin directory of your Tomcat and just click shutdown.batch file. Okay, so now your Tomcat server is stopped. You can also confirm it by checking to the checking from this tab. Okay, so you no longer see this 12408 PID in the left tab. Okay, so that means your Tomcat server is also stopped. Now you just have to start it up. Okay, so server is started up. Now we just now need to go and check again in the JVM. So no, now new PID generated like 19648. So I close this, open this. Okay, so you can also see this argument that we have given new size equal to 120 MB. We can also confirm it going to the Visual GC tab. Now you can see hidden space is allocated more memory, 119 MB, right? Okay, so now let's try to run the same set of tests and try to check if what it is resolving your issue or not. Okay, so before that, I think we need to regenerate the number of users. We need to run the script of create users. Yes, if someone is having some questions, Himanshu, you having some questions? I think there is some noise coming up from your end. Okay, thank you. Okay, so I already created this script and I also shared this with you guys to create the number of users for application. No? So we are using 50 users. So I just start this test. Okay. Table. One, 11, 12, 13, 14, 15, 16, 17, 19, 22. Okay, so it takes just some time to get all the users set up. Okay, till then we can just check the regular how it is working. Now you can see this graph over here. So we started creating user. So this activity is also spiked up some behavior in your heap utilization. You can also notice that in monitor tab. Yes, you can see that the threads has increased, and also in the monitor tab you can see this behavior. So some GCs are happened over here, right? Some spikes are there because we initiated this object creating users script. Same, you can see the left tab GC activity. CPU usage is almost 31%, 37% for GC for this particular period, right? Where when we started the 50 threads at each at a stretch, so there is no ramp up given for the 50 threads. All have started at the same point. So you can see that maximum CPU utilization is 41.7% out of whatever the it's used. So GC activity is using high CPU, right? So now let's just check if it is finished or not. Okay, okay. So user creation is now finished. So we should be able to go to run the test again and to observe the. Let me just try to rename the results file first. Okay, because we will have this result files to analyze further. So GC file. Then we have. I don't know where we have given this. The scripts. Yes, so this is the GTL file that we have given, right? Okay, so I just need to rename this. Yes. Old. Okay, so it will not overwrite it when we run the test. It will not overwrite it. Okay, so the same command, same thing. So we are just running the same test again, just trying to observe that what is happening. Okay, so I've already started the test. At the background we can see in the JVisual VM we can see clearly that monitoring tab, there is consecutive ups and downs. So like let's move to the visual GC tab again. Okay, so now again you can see this it is moving up and down, up and down. So high collections are happening. So 25 collections so far in hidden space. Earlier it was having some high rate, right, for having for this GC. Okay, so you think this activity stop now. So this is some clue, or we can say some hint that we need to check the application behavior. So now we can check, see again you are seeing the error counts increased, right? So that means this is the issue. You are running on low hidden space. That's why you are getting this errors again and again, and you are having this issue because of there is no enough space for new objects for getting created, and due to which your GC activity is piling up. You can see this GC activity is spiking up your CPU, right? So at maximum CPU, you can see 37% is used for within this span, right? So this is an issue, right? Now it is clear that this is an issue. How do you fix it? So we already tried to give maximum allocation for your heap, the new size, right? But still it is not able to accommodate the object creation rate. Okay, so now we have come to the conclusion that there are two things. First is you need to increase the hidden space, and or you need to check with the developers for your object creation rate. Okay, if the developer is confirming that object creation rate is as expected for the application behavior, we are left with the other option to tune the heap area. Okay, so we need to increase the heap beyond this, right? So this is how we do the testing part, right? This is how we analyze. So we need to pinpoint first, and we need to check whether this is actually causing an issue. If it is causing an issue, what are the possible reasons? Okay, and then find out the reasons, and then we need to properly select an option. If the object creation rate was an issue, in that case the developer will have to work on it, right? We need not to change the configurations of our heap. But if the hidden space is issue, we need to change the configuration of heap. So we need to increase the total heap size as well, right? So let me just go back again. So this is the process that we will be I mean this is the continued process. So increase the heap, I'm just doubling it. So I want you guys to try these things on your own, and let's just allocate some. Okay, so 320 will be too large, right? Let's see, 256 MB for your old new generation. So I would urge you guys to try these options and see what is happening and try to understand what is happening. Okay, I think I mentioned you guys to tell one more thing. So whenever you are doing these things, it is also important you check your application logs, right? So now for us, our logs would be generated over here, right? So this will be your catalina.log post manager local host. Okay, so you can see if you go through the logs, you can see there should be some errors coming in, due to which we are not seeing any activities. See, you can see this error, unhandled exception. So these errors are the cause of having no space available to create new more objects in the heap, right? So you can see this error is also reported as a severe, right? So this is how you can confirm that whether this consecutive GCs is a cause, is a problem as for your application performance or not, right? So generally for most of the applications it will throw you HTTP 503 or HTTP 500, but now as we are already running this server on localhost, I mean the same machine we are running this, so we are not able to see the HTTP 500 or 503. There are some other errors which are coming up due to this. Okay, okay. One more thing, I think we need to make sure that while giving these options, Catalina.bat options, so we have we have given multiple options like for GC date timestamp, print GC details. There is one more option to take heap dump when there is out of memory errors, right? So -xx heap dump out of memory, this kind. So I don't remember exactly what is the option, but it is the option available, so you just need to include that as well. So whenever your test is running, so in that case, in that way, if the out of memory error occurs, you will automatically have a heap dump. Okay, so you will not lose anything, or you will not lose any data. Okay, let's just try this one more time and let's just see if what happens now. Now we already increased the heap size and all these things. So again we need to do is first stop the test. Okay, it stopped. Okay, the Tomcat is also stopped now. We have made the changes in the Catalina, right? Just need to restart the Tomcat. We'll come back to your question, Chandra. Okay, so Tomcat started now. Just try to confirm it with this. Okay, so new PID generated. Opening it. So new size is 256. XMX is 512. Confirm it with Visual GC also. You can see 255 MBs allocated to new size. Okay. Quickly go to the JMeter. Try running the same test again. Okay, so let's discuss what Chandra has to say. What are the possible other options if development team don't want to increase the heap size for frequent GC issue? Okay, so the one possible option that we already discussed is that the object creation rate. If the development there are two cases, Chandra. So development team will not control the heap size. They are just there to check the code area. So the heap size and all these things, that would be the area of working for your architect, application architect. Okay, so we need to get all these guys in a single meeting, and we know we need to represent our results or our observations, whatever we have uh, faced. So if we are facing this dilemma that the object creation rate is high, so either you manage the object creation rate with developing your optimizing your development code to create the minimum required objects, and either you increase the heap size, right? Because there is no other option, because business is already asking for having 500 concurrent users load, and we are testing for that only, right? So if they are expecting to have 500 concurrent users in production, so they have to take care of this. So either they should increase the heap size, or they should check the code again to create the minimum objects, right? So one more thing comes in the picture over is the object sizes that we also discussed. So developer plays a key role over here. So he needs to assess everything. So in that case we can generate a heap dump. I mean, if you're facing this issue, or if you're observing this issue consecutively, what we can do is we can take a heap dump of the application whenever we are facing this issue. Once this heap dump is collected, we just share this dump, or we can we just do analysis of the heap dump, and we share our analysis with developers. So what would be the key points reported in this case? First, the maximum number of objects created for which class, right? Second is the maximum highest size of the objects created, and for which class it is created. And third is the object creation rate, that how many objects are created within the specific time. So these are the three main things that you will report to the development, and they are expected to improve it, right? So there is no other option apart from this. Either you need to manage your object creation rate by optimizing the code, or creating the minimum required object sizes, or you need to increase your hidden space to accommodate all the users, or all the objects that are expected to get created. Okay, so I think the users are created now. So let's just go and check in the JVisual VM. Is there any activity? Yes, so we can see there was small activity. In the monitor tab, we can see there are some small spikes up there for GC. Okay, so now just do the same thing again. Just try to run the test. Okay, so it started now. You can see. Okay, so hidden space is again filling up rapidly. Now we just need to check whether this behavior can sustain, or whether still it is having an issue, because we have now we have doubled the sizes for hidden space. So if this is sustaining for a longer duration, that means we are good with this particular option that we are given. Shortcut to copy and paste on the console channel, you just copy wherever and just right click on the console. Okay, now the error rate is increased. Go to the Tomcat Manager app. Okay, current thread count is used 33, maximum 200. Okay, so this is also an issue that your maximum thread count is reaching. So you are having max 200 threads allocated and you are also giving 200 threads. So there is no breathing space for Tomcat to do their own work. So out of 200 threads, you are getting almost 181 threads errored out, and 10 current threads are busy. So because the daemon threads have highest priority over application threads, that's why Tomcat is uh, you know reserving these threads for its own purpose. You can just go need to increase the threads, where we can do that in the Catalina. In Catalina, I don't think that we can control the number of threads. For that, we need to check some other file, server.xml. Okay, so there is no activity now. So guys, this is the kind of exercise that we need to perform at our end. So yes, today we discussed about this GC, one cause of consecutive GCs. Tomorrow we will be having another Java problem, Java hang problem. Right. So for as of now, I just want you guys to try to play around with this and try to check what is what are your observations, how you can try to give more space, hidden space, and if it is still it is having, then you need to check some other solutions, right? So this is the one case that we discussed today, that consecutive GCs, how we can tackle with consecutive GCs, and what are the possible causes of having consecutive GCs in your application. First is your object creation rate, and second is your hidden space allocation, right? If there is no space for young objects to be created, you will have a consecutive GCs running on your system. Okay, so as of this is for today's session. In tomorrow's session, we will see another Java problem, another heap related problem, and we'll try to solve, try to check how we can solve this heap related problem and what are the possible reasons for that problem. Okay, so try this exercise today. I think you might already get an idea that what you have to do. So if you already have set up this JPage Store application and all this tool set on your desk, so it's well and good. So again, I will try to document all the things, and I will send out an email describing the steps what we have to do. But it will be similar to that earlier exercise that we did. Let me just open the previous email. Yeah, so it will be somewhat similar to this only. Yeah, so this is the exercise, the last exercise that we have that we did for the JVM and JMC, right? So create first you need to create the users, then you need to run the test, right? In between you need to change the options, right? So for XMX, XMS, so while trying out the options, you also try to understand what is causing what issue, right? Tomorrow we will discuss another issue for Java and JVM heap. So as of now, we are done for this sessions. So if any questions you have, please let me know so we can take those questions and sign off for today's session. What are the, so okay, I already covered the Chandra's question. So there is one more. Okay. So any other question, guys?
Then, I have a question in
Yes, Chandra.
that visual we have that, right? Can you open that?
So what? What do you want me to open, Chandra?
Can you hear me?
Yes, yes, I can hear you.
Can you open that visual part where we see that all the graphs?
Yes.
So we have the thread part, right? So
Mhm.
yeah, here we have this. I have a doubt regarding this live peak and daemon and live. So how are these like calculated? What is this live peak means? I have.
Yes, so live peak threads and live threads. Okay. So what happens in the threads part is that live threads are your threads which are actually running now. If you go to this threads tab, you will able to see this. There are different types of threads available, right? Just minimize this. Okay. So you can see the status green is running. So whatever the running threads are there which are live. So these will be calculated over here, and it will show you this live threads. Okay. Second is live peak. Is that what is live peak? Live peak is nothing but the maximum number of threads it reached till the time your JVM is up and running. What were the maximum threads were live during that time? Okay, so it is just the peak count. Like we know maximum count of CPU that we have. The same that it is the peak count, that what was the maximum number of threads were live at a particular time. Okay, then comes your daemon threads. So daemon threads are nothing but your threads which are required by your JVM to work. So now you can see this AJP Neo connections are there, AJP Neo client acceptor, so RMI JMX server connection. So these are some daemon threads. So these are by default required by your JVM. So if you can just filter out your here live threads, you can see just the live threads or running over here. So we can also check this when you're starting the test. Okay, so check whether see, so this finalizer thread, this reference handler, this signal dispatcher, attached listener, so these are not the application threads. These are the threads which required by your JVM, which has been started by your JVM. So these threads will include these threads will have a highest priority on the other threads, right? So this will also include the, so these are the application threads that we have. Now you can see finished threads. So all these threads were the running threads for application. So now these are finished. So we almost have 200, we almost give 200 threads. So now these are finished. So you can see the max count. What is the thread for this? So okay, now it will increase consecutively because some new threads are coming up again and finishing their work and going up. Okay, so this monitor tab actually gives you a total, data of what are the total threads. So whenever you start your JVM, anyhow you will still at least minimum 10 to 15 threads live. Whenever you restart your, okay, so just let me just show you trying restarting this JVM. Okay, I just shut it down the Tomcat server now. Just confirm it. There is no activity now. See? Okay. So there is no activity. Now let's again restart it. So as soon as your JVM is started, you will have some mandatory threads available, which will be running and which will be live in your JVM. Okay, so now it started again. Let's check it again. So no PID generated. Okay. Now you can see some 40 threads are already there. So we have not started the application yet. So we have not accessed the application yet, but there are some already threads are running. 40 to 50 threads are already running. Out of 49 threads, you can see daemon is 46. Right? Daemon threads are nothing but the threads which are triggered by your JVM. So in the threads tab, you can go and see this JMX server connection timeout, RMI scheduler, RMI TCP connection. So these are the threads which are of your JVM, which has been triggered by your AJP Neo. All these AJP Neo threads, these are your JVM threads. So what these threads do, we also cannot actually tell what these threads are doing. Okay, I think our test is running in the background. No, we already stopped it. Okay, so finalizer thread, reference and so these are all the daemon threads. You can also see this GC daemon thread. So there is a separate thread for GC also, which is again triggered by your JVM, right? So unless and until we have any application work, this count will remain same. So it won't increase beyond this 49, right? If you do some activity in the application, like just go to the Tomcat manager and just try to check if what are the number of threads are active as of now. You see there is only one thread active, get manager status. That is also for Tomcat. That is not for application. Let me just sign in, log in. Okay, now if I go again and now if I check, I should see one more thread. Now you can see there is one more thread. R is there ready. The same can be observed over here. You can see it fluctuated over here. It increased this and again coming down to 48. So when we start the actual test, this will again start fluctuating, right? So number of threads we can you can see in this previous graph, previous snapshot, right? So earlier it was 40, 50. Then when we start the JVM, those we call daemon threads, we will have a, oh I think I was, yeah, I think some voice was breaked over there. Okay, we will have a detailed discussion on this all these threads when we have a thread dump analysis session. Okay. So as of now, you just need to check that what are the number of threads are running and how many threads are there, peak threads are there. Okay, Chandra, I think that is, I think there are two Chandra. So Chandra, you joined from web as well as from other, kya? Acha, you joined audio conference separately.
Yeah.
Okay, okay, no issues.
So, then I have one last question. So, how is this heap calculated? And if it is a big enterprise application, how they are going to calculate it? What will be then approximately what will be the size of heap in that case?
What threads you want to calculate?
No, no. So if it is a larger enterprise application,
Mm-hmm.
so the time how the heap is calculated for that application, and
Heap
what
is
will
how the heap is calculated. You want to ask the heap, right? Hello, Chandra. You want to
yeah,
understand about the heap, right?
yeah.
Okay. So there are some standard measures for heap. Okay. So you can see this maximum young generation should be your 1/4 the size of your max heap size, right? So there are some standard measures given, but it also includes some kind of measures like you need to have some benchmarking done first, right? So there are some cases, let's say for example, there is a standard Java enterprise application in the production, which is expected to run 5,000 concurrent users load. Okay, but now at present it is only serving 200 users. Okay, so we cannot use the heap configuration for 5,000 users now only. Now this is a trend in the market now. The they will not reserve that amount of memory for your heap because they are expecting to increase the load in future. Instead, they will have a benchmark done first that for 200 users, what is the maximum required heap to function this 200 users properly without facing any issues. Once this benchmark is done, they will imply those heap options to the architecture, to the JVM. So first thing is that there is a specific measure. So there are standard options like heap sizes should not JVM heap size should not go beyond the 1/4 of your host RAM size. So if you're having 8 GB, so it should not go beyond 2 GB. So maximum size you can allocate is 2 GB, like that. So there are some standard measures. Apart from that, we also need to consider the different differences like what are the expected load and whether if it is going to increase in future, at what rate it is going to increase, right? And what sort of space we want to reserve. Okay, and nowadays what is happening is that multiple organizations, we see that there are multiple JVMs are hosted on a single server, right? They will have a single server with very good and very high computing power, like 24 or 64 CPUs, and they will have 1 TB of RAM. And in that case, in that server they will host multiple JVMs for different applications. So in that case also, we need to make sure that whether if your JVM is hosted on a shared server or on a shared host, in that case I need to make sure that my JVM is properly utilizing the memory. Or if it is not required for my JVM as of now, I can bring down the heap uses. Some cases are there where a GC has been caused due to high heap sizes also. There is this issue we'll again discuss in upcoming sessions where we will discuss another problem. What is so giving up high heap size or increasing the hidden space will always not solve your issue, because as the larger the heap size, the larger the time it will take to clear the space, right? So the maximum heap size is there. It will take the maximum time to collect the size, or recollect the size. So it is not advised to have your hidden space beyond 1/8 of or 1/6 of your old generation. So there are some standard measures which architectures or architects will consider while designing this application. Okay, Chandra.
Yeah. Thank you.
Yeah. Any more questions from anyone? Who's this? Disha Harika, who just joined this Redmi 6 left. She is not part of the training, I guess. Okay, so we will conclude today's session, guys. So please try these things on your own. So as as far it goes with your own understanding. It will help to understand you the issue properly. Because the purpose of our training session is not to teach you performance engineering. Yeah, engineering cannot be actually taught or taught. So we are here to inherit that thought process inside you. So you need to think in that perspective, that what could be the possible issue, where we should look. So this is nothing that's what we call engineering, right? So it's no rocket science or nothing. So you just need to be proactive, or you just need to check, you need to be curious all the time, and you just need to check the different sections. We are just here guiding you to that path, that how do how do you convert your testing observations, or how do you convert your whatever the stats you collected, how do you convert it to the proper engineering input to your development guys or to your teams. So it will help you greatly if you try to do these things on your own. Just try to understand what is there in this Catalina file, what is there is in Tomcat Catalina file, what are the options that we need to change, what are the performance related matrices that we can monitor for from the Tomcat server. Because Tomcat also have this manager portal. So Tomcat Manager is a portal where you can get the Tomcat status. You can see. So this is PS hidden space. So Tomcat is it is also listed out all the heap memory. What is the old generation? What is the heap memory? Survivor space and everything. You get this data. Try to explore more and more. And that's how you become an engineer, right? By exploring yourselves. So I will urge you guys to go through. Next session will have tomorrow, Santosh, at the same time. Okay, so we will discuss the another one more issue with heap memory, and we'll try to fix it out the same way that we did today, that what could be the possible reasons and what could be the possible solutions. So right, so before that also, I also want you guys to try these things out and let me know if you're facing some difficulties or facing any issues of for doing this. So no, so as these sessions becomes interactive, I will also get encouraged to give more and more details to you guys. Okay, so if there are no questions, so let's conclude today's session, and let's meet tomorrow at the same time.
Chetan, it
Yes,
will be
Chandra.
really, yeah, if we it will be really helpful if we have the class on alternative days, because we'll get some time to practice. Otherwise, if today we have the class, we won't get the time. Tomorrow
Okay.
there is a.
Yeah, so okay, no issues. We can have this on alternate days as well. No problem, Chandra. I will give you some time to practice these things out and all these things. Okay, no issues. Okay, so I will update the scheduler accordingly. But as of now, this class is for the same topic. So I think we will have the tomorrow's class, and then we'll have the alternates. Okay.
Okay.
Okay, because you can practice the same things in one session only. Okay, guys. So thanks for attending, and even if have any questions that you may forget to ask during the session, please post it through the email, or you can post it in the chat group. Okay, bye bye. Good evening, good night, good morning. I'll just closing the meeting now.